Good to know. All right, guys, we're going to talk to you today about composite design patterns. So, what is a composite design pattern? It is a structural design pattern. It composes objects into a tree-like structure to represent part-whole hierarchies. It lets clients treat individual objects and compositions of objects uniformly. In object-oriented programming, a composite is an object designed as a composition of one or more similar objects. Think of an array list of objects. The array list is a composite that holds a lot of similar objects, all exhibiting similar functionality. This is known as a has-a relationship between objects. The key concept is that you can manipulate a single instance of the object just as you would manipulate a group of them. The operations you can perform on all the composite objects often have a least common denominator relationship.
So there's four main parts of the composite pattern. The first part is the component, which declares the interface for objects in the composition and for accessing and managing its child components. It also implements default behavior for the interface common to all classes as appropriate. So basically just sets the outline for all of the child classes. A leaf defines behavior for primitive objects in the composition. It represents leaf objects in the composition. A composite stores child components and implements child-related operations in the component interface. So the composite is basically the object that will hold the leaves or other composites in an array list or any other collection. And then the client manipulates the object in the composition through the component interface.
So, the operations in the composite design pattern. The client uses the component class interface to interact with objects in the composition structure. This means that when you're writing the main driver program, you will only ever implement the components. If the recipient is a leaf, then the request is handled directly. If the recipient is a composite, then it usually forwards the request to its child components, possibly performing additional operations before and after forwarding the request.
So the problems that this pattern solves is when you're dealing with a tree structured set of data, programmers often have to discriminate between a leaf node and a branch. This makes code a lot more complex and therefore it's more error prone. The solution to this problem is an interface that allows treating complex and primitive objects uniformly.
So, what does this look like? This is a simple example where we can see the file at the top is the component. Within this, you have the text file, which is a leaf, and a directory, which is a composite. And both of them implement, you can see the inheritance file. This means that regardless of if you're making a text file or you're making a directory, you're still going to implement the component of file. On the left, you can see how the tree structure kind of works, where a composite can hold other composites, other leaves, or just leaves.
So this is the first example that we made. I'm going to start off by just showing the code first. Let me figure out how to do that. So the component that we went with this one is an employee class. The values in it are employee ID, name, salary, and then you have to implement a toString method. And under that, we have a manager class, which extends the employee abstract class. So in this case, the manager is an example of a composite because it also holds other employees under it. But at the same time, it implements the employee interface by storing the employee ID, name, and salary, and then it just calls the superclass of employee to initialize it. And you can add employees, you can remove employees, and then we have the toString method here. And another composite in this is project lead, and this holds other employees, basically the same thing as manager. And an example of what a leaf node in this would be is developer, because typically people don't work under the developers. They're going to be the like the leaf of the class. They're not going to have any nodes under them. And then an example of the client would be just like a main method right here where all the data is initialized. So we make 5 developers, and then we have 2 leads. We have Dr. Wei, who's making $400,000 a year, and then we have 1 manager. And for Dr. Wei, we'll add developers 1 and 2 to his team, and then for Dr. Ma, we'll add developers 3 and 4 to his team. And adding these to them is adding leaf nodes under their composite node. And then the manager who oversees everything, we're going to add the, after we add the developers to the project leads, we're going to add the project leads to the manager. And then we also have 1 developer working directly under the manager. And then whenever we run this, it's not formatted the best, but you get your manager right here and the first project lead, and then the 2 developers that work under him. And then you have your other project lead under the manager and the 2 developers that work under him. And then you have your single developer who works under the manager. So if we go back to the slide, we can see this in a diagram. So we have our component here, which every class owner conforms to that interface. You have your manager, which is a composite because it has a collection of employees working on it. You have your project over here, and it's leaf nodes under it. And that's basically it for this example.
So for my example, I decided to use a catalog for a store. And you can see in this diagram that the catalog component is the component, and both the product and the product catalog inherit this. And you can see through the aggregation that the product catalog will be the composite in this class, and the product will be the leaf, which means that product catalogs can have other product catalogs stored in them, as well as other an aggregation of leaves, which are the products. So I'm going to pull up my code. So the first class I have here is the catalog component, and you can see in lines 7 through 12, we write the composite methods add and remove. That adds and removes catalog component objects respectively. Both the methods can add or remove products from catalog or a catalog from the parent catalog. In line 20 through 28, we wrote the methods get name, get price, and print. And these methods apply to both product and product catalog. And although at first look, get price might not seem very relevant, but being a good programmer, we know that we might need to later find the price of the products in a catalog. So in this class, we noticed that each method throws an exception called unsupported operation exception. And from the composite pattern design point of view, this is not necessary, but we do it because some methods will only be relevant to product, while some will only be relevant to product catalog. For the irrelevant methods, product and product catalog don't need to do anything. They just have to inherit them by default, since this is a public abstract class that they're both going to be inheriting. So if some code accidentally calls them, the exception will get thrown. So then we have the product class. It's very simple. It's the leaf class, so we don't have to worry about it having children. So we extend catalog component and we provide implementation of the operation methods that we need: get name, get price, and print. And then we have the product catalog class. So this is a composite. So we must implement both operation and composite methods. So we instantiate an array list. One sec. We instantiate an array list to hold the catalog component objects, and the get name method returns the name of the catalog component object, and the print method uses a for each loop to traverse the products in the array list and print out their information. The add method adds a catalog component object passed to it to the array list, and the remove does the same thing, but obviously removes it. So this is our client in this case, just this test using JUnit. Good stuff. So what we'll do is we'll create a primary products for a main catalog, and we'll create a composite product catalog to add some female products to it, and we'll do the same, add some kid products to it, and then add a primary catalog and add primary products and new catalogs to it. And you can see here, the way I implemented it, we're always creating a catalog component. We're never creating just a product or a product catalog, because they all extend catalog component. We are all treating them as the same uniform object, even though they do different things. So we can just run this test, and you can already see the output in the console. But you'll see that regardless of the catalog, you have new catalog, kid catalog, main catalog. We call main catalog and print, and since it's holding all of them, you will get all the information printed out, regardless of how it is treated as a leaf or a composite object. All right, so when to use the composite design pattern? When clients need to ignore the difference between compositions of objects and the individual objects themselves, and they can treat them the same way. So if programmers find that they're using multiple objects in the same way and often have nearly identical code to handle each of them, then composite is a good choice. It is less complex in this situation to treat primitives and composites as homogeneous. Also for efficiency, the less number of objects reduces memory usage, and it reduces the execution time of our program by sharing objects.
So when do you not use the composite design pattern? So the composite design pattern makes it harder to restrict the type of components of a composite. It should not be used when you don't want to represent a full or partial hierarchy of the objects. Composite design pattern can make the design overly general. It makes it harder to restrict the components of a composite. Sometimes you want a composite to have only certain components. With composite, you can't rely on the type of system to enforce those constraints for you. Instead, you'll have to initialize runtime checks.
Okay, so for the usage in JDK for the composite design pattern, this is the only thing I could find online, and there wasn't much of an explanation for it, and it was very difficult to find this at all. But as you can see in Java AWT, there's containers and they add components, and this is a classic implementation of the composite structure. And then also in JavaX faces, there's UI components that have children of other components making, so it's composite because the children can have other children, and there's just a tree structure whenever you're using a container of components.
So for our programming question, we're going to have you create a sample TCU computer science department using the composite structure, and all members of the structure conform to an abstract class TCU employee. Student workers will work for a faculty, and faculty will work for a department head. So TCU employee is the component, and it has the values ID, name, and email. The composite classes are department head and faculty. And keep in mind that student workers can also work for a department head. So there can be a leaf node coming off of a department head, and the leaf nodes are of type student worker.
So in conclusion, the essence of composite pattern is the ability for a client to perform operations on an object without needing to know if there are any nested objects within that object. In the composite pattern, you have to define the composite methods at the root of the class hierarchy, and clients could mistakenly attempt to add or remove objects from leaf objects because they're all treated the same. This design pattern is a starting point to work from that can be adapted to your requirements. Like in example 2, by making the root component an abstract class and throwing exceptions in its composite methods, just in case the code accidentally calls something it shouldn't be able to do. And I think that's it.